All right, it's Kalen Langley with ECE 275 Digital Design. This is part two, in that I forgot to turn the screen sharing on prior to taking that last recording, so I was talking over a blank screen. So we're going to do this again. But we're going to be using ModelSim to um, check a couple Boolean expressions to determine whether they're equivalent or not from the handout. For F1 and F2 and F3 and F4. So we're going to start with F1 and F2. On the previous video, we learned that F1 and F2 are not equivalent. You can see that here just in the first row. They're already opposite of one another, so they're not equivalent. And then F3 and F4, which we'll check after this, and they are equivalent all the way through, so they're going to be a mirror image of one another. We're going to be using a test bench and ModelSim this go around. Um, Prior to the previous video, we did not use a test bench. We just added the wave and had to move this window around all over the place and play with the clock settings to find each iteration. That was rather cumbersome. This is really nice because we can step everything through and test each iteration for A, B, C, and D, all the different combinations. And then I set it up just like this truth table. So starting from right to left, we're going to be starting to run up our binary bits or numbers, however you want to call them. So we'll start all off. D is on, D turns off, it goes to C, C and D, then B, and then these turns off. So it's really easy and allows you to quickly check your logic. So right away, A, B, C, and D are all off, and F1 and F2 are 1 and 0. 1 and 2 are 1 and 0. You can see here. We're going to go to D. D is on. F1 is 0. F2 is 1. So they flip-flopped. Now we're going to go to C. C is on, D is off. F1 and F2 are 1 and 1. You can see that here and here. Now C and D. C and D, they turn off. Sorry, they didn't both turn off. C and D, F1 is 0, F2 is 1. 1 is 0, F2 is 1. That looks good there. Now to B. B, F1 is 1, F2 is 0. B, F1 is 1, F2 is 0. They flip-flop again. When we go to BD, BD, F1 is 0, F2 is 1. Now to BC, BC, F1 is 1, F2 is 1. You can see that here. BCD, BCD, 1 and 1, BCD, 1 and 1. Now we're going to A, F1 is 1, F2 is 1, A, F1 is 1, F2 is 1. Now to AD, AD, 1 and 1, AD, 1 and 1, AC, here, AC, 1 and 1, AC, 1 and 1, ACD, ACD, 0, 1, ACD, 0, 1 for F1 and F2. To AB, AB, 1, 0, AB, 1, 0. Then to ABD, ABD, 0, 1, ABD, 0, 1, ABC, ABC, 1, 0, ABC, 1, 0. And then to A, B, C, and D, they both turn on for F1 and F2 again. All right, so that logic looks good. All our bits turned on as they should per the expression. And we're going to do F3 and F4 now. Now these two are equivalent. So that being said, every single time they turn on, they should mirror one another, unlike up here where we had several iterations where they were opposite or did not equal one another. Excuse me. All right. Starting at the beginning when they're all off. For A, B, C, and D, F3 and F4 are ones, as you can see here. Now going to D. D is on. F3 and F4 turn off. Now to C. They stay off, as you can see here. That's a C and D. C and D, they're both off still. And that's looking good. Now to B. B is on. F1, or sorry, F3 and F4 are ones, as you can see here. Now to B and D. B and D, they stay on. B and D, looks good. B and C, they turn off, as you can see here for B and C. F3 and F4 are off. Now B, C, D, no change. F3 and F4 are off. Now to A, they turn on. A, nothing else on. F3, F4 are ones. Truth table's tracking correctly. AD, A and D, 101. AD, 101. A and C now. AC, 101. Looks good. ACD, they turn off. ACD, they turn off for F3 and F4. Now AB, we turn back on. AB, F3 and F4 are 1. Scroll down a little bit. So we're at AB now. So the next would be AD. ABD. Right here. So they stay on. ABD stayed on. Next is ABC. ABC. 101. 101. A, B, C, and D. They're all on. All right, so that concludes this video for ModelSim. Thank you.